Good evening, Sachin sir.
Good evening, doctor. How are you?
Fine, sir. Sir, please check whether it's sharing in good way or that one.
Okay,
Let's
okay.
see.
Give me a second.
Uh,
Let me know if you are able to see my screen. Are you able to see my screen, doctor?
Sir.
Yeah. Are you able to see, Dr. Raman?
Yes, sir. Yes, sir.
Okay, perfect. So should I take it off and probably share one more time when
It's okay,
when
sir.
we start?
You can keep, sir, because since you are the first speaker, sir, you can keep. No issues, sir.
Okay, perfect. Should I switch on my video? Let me know if it is
Yeah, it's coming, sir.
fine. Okay.
Sir, let's wait for 2 more minutes, 1 or 2 minutes. 34 participant has joined
Right.
and expected around 80 plus. So let's wait for 2 more minutes.
No problem.
Uh,
Thank you.
Sir, no issue. We can start now. Raman sir.
हाँ एक 2 मिनट वेट कर लेते हैं वैसे अभी
Okay. वैसे okay.
Doctor, is it also been on the YouTube link that was shared?
I think we can start, sir. So good evening, everyone. A very warm welcome to all the participants joining us on the day 18th of our 21 days online training programs. And today program we will focus mainly on the theme AI-driven maize value chain and dual feedstock based ethanol industries. As we know that artificial intelligence is rapidly transforming agriculture by enabling precision farming, efficient supply chains, and data-driven decision making across the value chain. So it's my pleasure to introduce our first speaker, Mr. Sachin, founder and director of Root Goods Private Limited, Karnataka. And Root Goods is one of our incubatee also. And our speaker is an agri-tech entrepreneur and co-founder of Root Goods, a AI-driven agriculture technology startup established in 2019. So his work mainly focus on leveraging artificial intelligence, digital agriculture, and data-driven supply solutions to improve productivity, market linkage, and value chain efficiency for farmers. So today he will deliver an expert talk on role of AI in maize value chain. So with this introduction, I warmly invite Mr. Sachin to deliver his expert talk. Sir, over to you, sir.
Thank you, Dr. Raman. Thank you so much. Thank you, Indians of Maize Research, for inviting Roots Goods to be part of this 21-day program. So, yeah, my name is Sachin. Once again, I'm the CEO of a company called Roots Goods Private Limited. So we have been working on the company Roots Goods from last 8 years. And Dr. Raman, can you confirm if you can hear me? There's no problem with video and audio, right?
So it's loud and clear, sir.
Okay, perfect. So yeah, thanks again. So the idea of starting the company initially was started as a spin-off of my thesis in Technical Institute of Munich in Germany. It was about carbon emission. Agriculture was a small part of it. So because agriculture was part of it, when I finished my thesis, the idea was to use the kind of research data for the further research or company. So those are two options available for me. So I spoke with my teammates and also researchers in India and also there. So my thesis was in both India and Germany. It was funded from both the governments. So based on the suggestions, from different experts, I came back to India, incubated initially at the University of Agricultural Sciences, Bangalore. There we are part of a business. We're part of a incubation program, and they chose us mainly to start a project called Maize Business School. Maize Business School was in Indian government's projects, which was executed in different parts of India. And in the Maize Business School, especially it was University of Agriculture in Bangalore and mostly in central part of Karnataka where we started out the project. There are part of the project as a company was to identify how we can improvise the market access. So that's where the interest of solving and understanding the market research, market access issue came up. So what we did, we built a SaaS platform, very simple platform on which farmers can interact on the with us initially as a company, and also experts from universities would also come in. So it's a SaaS platform for presently it's a SaaS platform for quality assessment of agriculture crops. Basically, we use this quality assessment primarily in post-harvest. Now we have introduced the quality of the seed, quality of the plant, and eventually the quality of the harvested maize. So that's where we are right now. And coming back to where I was explaining during the Maize Business School, our challenge initially was to understand what the farmer and the buyers were facing. So we identified both of them were using subjective ways of assessing the quality. So there we found out an opportunity saying that how do we make it objective? Based on data, based on something which is neutral, not just biting with their teeth or just visually inspecting it. So there we identified both, not only the farmers but also the buyers as well. So both buyers and farmers were having this issue of how do we objectively assess it and how do we come to a price point. So that's where we understood there is a challenge that we can solve here. Initially, we started collecting the data from the farm level. Probably you can from the farm level and telling them what is the quality. However, as we progressed, we have introduced the intelligence of bioinformatics and genetics as well from the point of seed itself. Initially, when we started out, of course, it was post-harvest solution that we built. But right now, this is the 9th year for the company. And our primary focus is maize, just one crop, committed to that one crop, and build the solution across from the seed till it gets converted into starch, converted into animal feed or poultry feed. So that's the intention of choosing just one crop. Recently, we have built a platform, a solution which has been used by Karnataka state government in seed laboratories to identify whether this maize seed is getting germinated or not. You can see on the picture on the left-hand side, it clearly tells you whether the seed is getting semi-germinated, germinated, or is it a dead seed. So this is the starting point where the farmer and also the seed manufacturers can decide and get the certificates about the germination. That's the first part. So in order to do this, what we did, once the seed was selected and going into the land of the farms, we wanted to give a platform for the farmer where they can upload images. You can see in this left-hand side in the pre-harvest stage, farmers and FPOs, there is one image that has been uploaded. There is an infestation of worm there. When farmer uploads it and asks questions, the GPT or the chatbot we call it as Maize GPT, which is very specific to Maize. Like ChatGPT, for example, it's also the same concept as a chatbot where you can interact. And this is the question and answer sessions that comes along. But the one important aspect here is after you identify the solution, so you know the image, you ask the GPT. GPT is also on the left hand side. You can see the GPT is also telling, okay, this is the solution. This is what you're going through. But we have also added one more point here, which means that after identification using the images here, in this case, our GPT will connect them to the local vendors who can provide them solution, like pesticides, who are around 20 to 40 kilometers. And these vendors, input sale vendors, are vetted vendors. We have already checked whether they are valid vendors or not. So they will connect them. There will be cash on delivery. There will be offline meetings can be arranged from the farmer directly going to the vendors as well. So that's the usage of this GPT right now. But once we started out, it was mostly we were using large language models of, for example, the pay as you go, in like example, OpenAI's models or Cloud's. So these are the models when we started out using it, but we understood one challenge. The challenge was primarily the answer that these large language models were giving was not specific. Like you guys probably who are listening to this interaction could also probably seen those kind of challenges. Sometimes the specific needs of the questions will not be addressed because it's a large language model which identifies the solutions from the existing internet data, not which is available already, right? So we found out there is a need. Yeah, we found out there is a need of building a small language model specific to the Maize. So that's where this RootsCoutts as small language model also came in, where we identify if the question and answers that are coming through the GPT is correct or not, and then we teach that. So basically, we build the intelligence layer with our own data. So that's it's like a language which can be built between Maize growers, Maize buyers, Maize seed sellers, and Maize academic experts like from Indian Institute of Maize Research. So this is where the large language and the small language models usage are coming in, and we think we can provide solution in a faster way. So we have been, like Dr. Roman and the Indian Institute of Maize Research have also suggested that we are already being incubated there. We are thinking to work on that in a larger context with academicians who are in the call, or the farmers, progressive farmers, or the industry experts who are using these maize for different purposes. We are open for business, and we are open for collaborations to build this model. So specifically solves the solution for maize, different hybrids, genetic hybrids. We recently have been collaborating with CIMET as well, where the germplasm data or specific usage of the seed with specific location can be identified and provided to the seed industry, who can manufacture it and supply it to the farmers. And eventually that data, which can be taken out, probably like, for example, shelf life calculation data, can be taken to the warehouse management. That's what we did. So we went to the processing units. After the pre-harvest, in the post-harvest stage, we generate the quality certificate based on the harvested. You can see normal maize, broken maize, white fungus infections, broken civils. These are the different kind of differentiations that we do after the harvest and generate certificates. This is pure image processing. But we teach the YOLO models, for example. I'll give a simpler examples, which is available in the market. We teach it, and then we can deploy it to the market, where this kind of intelligence, which has been built through these YOLO models, can be utilized to generate certificates, for example. Once the certificate is generated, we connect them to the farmers and the buyers. And then both of them use the certificates to come to a price point. They do the interaction, basically negotiations, and then come to the transaction stage. So that's where we come in. We provide these certificates, connect them, both of them. We generate revenue in both ways, by connecting to the local vendors, connecting to the post-harvest buyers, both ways. So that's where the business model, where we are working at right now. And this exactly, the pre-harvest and post-harvest data is taken into the warehouses. How do we manage? Once you know the quality based on the barcodes on the bags, the warehouse managers can decide when do they resell it, or when do they use it for production of starch, production of poultry feed. So that decision-making capacity is also been inbuilt, because those intelligent bioinformatics data is taken into the warehouses and then eventually to the products, to the bioethanol or the DDGS that has been sold in India. So many of the challenges like aflatoxins can also be reduced. So that's where we are going in. We will also identify helping the buyers to identify whether the seed that they are buying, whether the harvested crop that they are buying has a high amylopectin to amylose ratio, whether it is suitable for manufacturing of starch or manufacturing of bioethanol, or quality protein, QPMs, whether it is suitable for poultry feed manufacturing. So this identification can also been provided right now for our buyers based on these bioinformatics data and the nutritional value data that we calculate. So these are the type of data that we also fill into the small language models, and also that language models can be utilized in the spectrum, not just the farmer, not just the buyer, but also academicians, but also the policymakers as well. So that's the holistic approach, and the open collaborative platform is what we are building along with the different stakeholders. Yeah, so quickly about what we are doing with machine learning, a quick introduction about what we are doing with post-harvest quality certificate. These are the quality parameters that comes along: size, color, fungus, foreign material, moisture, shelf life, and carbon. And once the farmers shares the information about their location and weather, which just will be generated, and these are patented data, patented technologies. We have patents here in India and also in Europe. We started out in Europe, so we have been working with PCT applications as well. We have trademarks, which was helping us to scale it and reach out to the farmers. We have our own mascot, which farmers identifies and connects, which will answer AI answers to the farmers through the mascots. It's a small frog called Frogo. That's the recent update from our side. So we're focusing on maize primarily, and this is the market is close to 66,000 crore, and we have connected so far around 56 FPOs covering close to 45 to 50,000 farmers, mostly started on in Karnataka, then Telangana, now in Punjab, the Tamil Nadu, and Andhra Pradesh recently. So that's where we are. And these are the go-to-market strategy that we take. We work with different institutes and different state levels who help us to identify the FPOs who are active and who can use this kind of AI technologies, or at least uploading images, understanding the certificates in the mobile phone. So that's how we have been working. And we started, like I said, we have started out in Karnataka. Now we are working in different parts of the India. We also piloted this in Nigeria, Canada, USA. We are trying to pilot this season. Australia, we haven't started any. And you can see this is some of the accreditations. Yeah, these are, recently Adani Group have chosen as one of the Zero Hunger Champion, awarded us India AI, which is a flagship program for Indian government. We have been selected one of the 5 agri-tech startups to build this AI technology very specific for Maize GPT, and putting it across to the different platforms like ENAM, ONDC as well. This is what we're building, a common operation business model for crops. However, we identified to grow to different crops, we have to actually have very confident data sets, a confident model which can provide solution from seed to conversion to the end product. So we are building this, connecting the main stakeholders, farmers, logistics, buyers, 3 main stakeholders who are pivoting around quality. So that's where we are focusing, and quality is the factor which would reduce the post-harvest loss from 22% to 5%. So that's where we are, and there are more couple of more demos that we could be showing as well as the interaction goes on. Dr. Roman, if there is any questions, interaction sessions, or probably we can show some demos, would also be interest for the viewers as well. Thank you.
Okay, sir. That if there is any such thing to show, then sir you can share, sir. If there is video.
Okay. Okay. Perfect. So give me a second. I'll just share. Yeah. So this is one of the, probably I will show it directly in about the seed level itself. We can start with seed, how the germination calculation is done. So this is one of the platform service, flagship service that we are providing, where different types of type of seeds can be selected and images will be uploaded. And once you upload the image, it will tell what are the different types of physical impurities are in the seeds, which is collected at the farm, collected at the market. So it will identify the seeds and it will provide what is the kind of, you can see the different foreign matters and different funguses that has been infected and what different leaves. If at all, if it is in the seed bags, it will identify and clearly tell the seed laboratories that it is the what is sold in the market is not completely pure. So after this step, if the impurity step is passed, then the seed laboratory people will upload from the germination chamber directly. Once they upload from the germination chamber, the AI will suggest what is exactly germinated seed, which are the number of seeds which are semi-germinated, which are the seeds which are dead. So all these kind of calculations are done based on ICAR standards, and this will be provided in terms of certificates for them. So this is about the seed solution that we have built. And in terms of GPT solution, which is used by the farmers, for example. So this is where farmers register themselves. They come and then here, for example, they are uploading an image and they are asking a question. So once they ask the question and upload the image, it will take a couple of seconds. And once the solution comes in, people can read that. And once they are reading it, you can see at the below, you can see there is a shop farming products option, which means our AI will also suggesting what are the different type of solution that are available for this kind of challenge. In this is a fall army challenge. So that's where it goes. It will take to a platform on which the vetted vendors are listed their commodities. You can see some of the solutions and they can buy it. This is how they buy it through the platform, and then they can pay, and then they can receive it. Either they can receive the delivery if it is close. If it is slightly far ahead, the 20 to 40 kilometers is the range that we are working with. If it is slightly far, they can visit the vendors who are slightly in the longer distance. So this is the second solution with the GPT solution. And yeah, there is SMs and quality certifications also. I can show you how the quality certificates has been used by the farmers. They download it in the same banner, and then they just need to upload image. They select the image, and then once they go, they just need to upload the image like this, a simple image. And once they upload, they have to upload the quantity and the unit for it, and just in a matter of 5 to 10 seconds, it will be done. The certificates will be showcased in the. You can see these are the certificate pending. Certificate after the certificate generation, our teammates will also check one more time about the quality of the image that has been shared. Once it's approved, the certificate is generated in 5 to 10 seconds. So this is a certificate that they will access onto the mobile phones. So it's basically the certificate sample I'll show you as well. Probably it will be more easier to understand at that level. You can see this is okay. No, this is the certificates used by the buyers. This is the certificate used by the farmer, for example. So you can see one of the farmers from FPOs has been using this certificate is generated from them before the transaction. And then these are the data, and this is the location from which the data has been shared. And when they send the location, what is the temperature, rainfall, humidity will be recorded from the satellite itself. And this is inference, 2% fungus, 14% moisture, color, grade 1, and also price suggestion is also given. What is the price that can be sold? This is for the farmers. And at the carbon level, we are also calculating the carbon that has been sequestered after they're working with us. So per kg of maize that is grown, what is the carbon saved as well is also recorded. This can be traded in the open markets, but we have not traded yet. But this is basically based on this data. You can see the maize, broken seed maize, black fungus leaf. So this is helpful for calculation of percentage of infestation, and then which will decide the quality. So this is the way the certificates are generated, and farmers can get an inference on the result. How much kg is fungus infested? What is the percentage of moisture? And what is the grade? Moisture is the one thing which is done by moisture meter. They upload it separately. That's the one thing which we use, or we cannot use photos directly so far. Let's see, we have remote calculation of maize as well, but it is not based on image, it's based on satellite data. But still we are using the moisture data so far. We are in the future, we are thinking about using the remote sensing of moisture inside the grain. We can probably discuss that as in some of the next event. That we have also patented that as well. It's not granted yet, but it is there. So this is where we are in terms of quality certificate generation. And yeah, these are about some technologies that we've built, and I'll show you one of the services that we have been. This is the certificates that our poultry feed manufacturers are seeing. So you can see the poultry feed procurement, and this is the certificate that the poultry feed manufacturers, they get it at their warehouses. So it will clearly tell them what is a fungal risk, aflatoxin risk, moisture risk, color grade, and foreign matters. And based on this, they can decide whether they can buy it. If they buy it, what price they can buy, how many days that they can, how many days they can store it. Those kind of very detailed thing will also be given in this certificates. There are 4 types of certificates that we give: poultry feed, animal feed, starch manufacturers, bioethanol. Bioethanol also has DDGS angle as well. We can discuss that as the time permits. But thanks for the time. I look forward to hear any questions from the audience. Thank you.
So we will take a very quick 1 to 2 questions. If anyone has a question, then you can answer this.
Or any feedback as well. It'd be great to hear. I know you guys are experts in the maize industry. Many of you are attending the call. Or any questions from the younger colleagues, students would also be great. Thank you.
Tushar sir, you are the next. You are industry expert, sir. Any comments, sir?
No, actually, Sachin, good one. Hi, I'm Dr. Tushar. For your overall AI generated things to be considered for the agriculture, the most interested part, Sachin, I like is that carbon capture moment you are taking out for the crop, and which is going to generate additional revenue to the farmers in future. Because that is linked with the energy GHG emissions right now coming out very strongly. And corn is the feedstock where bioenergy is considered as a backbone now for the development. So that I think it can be linked with the farmers, and in your app also, if you add the trade on, how to trade on them with the APOs and all.
Right.
So you are very good mileage for the LCA, what we are fighting it for. That's what I can say.
Thank you, doctor. Thank you. So we are trying to work on that. Like you said, clearly, it's like for me or for our company, it is like a second digital crop. Basically, from maize, there is one more crop that they're growing, which is carbon. So we're trying to leverage that in the market. Thanks for the feedback.
If there is no further question, then thank you so much, sir, for your excellent presentation, sir. Sir, it was very insightful, and so there is one question come on, sir, in the chat box. So what do you suggest I have to read it out.
Yeah, okay, I can read it. Don't worry. What do you suggest to some of the people who are starting in the general agri-tech? How is it easier after AI and machine learning? Oh, it's a great question because we have been spending time from last 8 years just focusing on one crop. We tried out. We thought about also working with a couple of more crops, which is always challenging to sustain if you focus on different crops. Our learning is that we focus on one crop and dig deep as much as possible to actually provide solution at the ground level. So most of you guys and also the industries, not only in India, across the world, like I said, we are trying to pilot in US. We did pilot in Canada and Nigeria as well. The two models are working well. One is input selling, output aggregation. So in any way there is companies are sustaining this is where these two sectors are, especially the fundraise or the larger context of solution makers when they raise large funds. So these are the two things that has been working out. This is one thing that we have learned, which is it helped us because instead of going and doing many things, just focus on one, which is focus on working on post-harvest initially, and at the same time when we chose to work on just one crop, it also gave us a confidence to do on inputs by using AI. So there's a lot of in terms of numbers, if you speak, some of my advisors and also guides and mentors also suggest, especially with agri background, they clearly said there is a possibility of having 1 or 2 unicorns in every districts in India because agriculture is so big. Yeah, just focus, I think, helped us to sustain so far. And the money and also providing solutions are there. Maybe the adoption rates are slightly challenging, so we have to build the trust and also make the technology very simpler so that anybody and everybody can understand. I think AI can be leveraged in a positive way. Thanks for the question, Rajkumar Mishraji. Thank you. And there's one more question: is there the same model can be applied in seed sector also, sir? Yes, we have used the seed. Seed is one first part, and the second part is the harvested kernels in maize, very specifically speaking. So in seed part, we are already using the quality assessment in terms of physical sorting, and the second part, we are also working with the assessment of germination and non-germination as well. So we are working in what level, including bioinformatics, genomics, those things can also be added, I think. So probably these are the things, futuristic frontier data sets that has been coming along, probably younger people and other startups could probably leverage, or traditionally also there's a lot of opportunities who can actually reach out to more farmers and build solutions. These are the two questions. Thanks, Shivkumar Singh ji, and thanks, R.K. Mishra ji. Thank you.
Once again, sir, thank you so much, sir, for your excellent presentation, sir.
Thank you, doctor, and all the best for everybody in the call. And we look forward for the collaboration, Dr. Raman, and the whole IMR. Thank you.
Yes, sir. Yes, sure, sure. So moving on to the next lecture, it's my pleasure to introduce our second speaker, Dr. Tushar Patel, Assistant Vice President, Bioenergy and Corporate Strategy, Pras Industries Limited. Dr. Patel is an expert in bioenergy, biofuel and bioeconomy, with over 15 years of experience in developing sustainable farm to low carbon fuel models. So he has played a key role in implementing commercial 2G ethanols and compressed biogas projects. And he has also worked closely with various governments of India committees to promote biofuel and circular bioeconomy. So today he will deliver an expert talk on multi-feed, multi-product biorefinery. So with this introduction, I warmly invite Dr. Tushar Patel to deliver his expert lecture. Sir, over to you, sir.
Thank you, doctor. It's pleasure. First of all, namaskar, and thanks to ICAR-IMR for arranging such an innovative thing. As a engineering technology provider company, it will always be happy that person from agriculture PhD. My PhD is in agriculture genetics from South Florida, but I work for our country, and that is what the proud moment, that a momentum of what international zone is taking out. Now same momentum Annadatta to Urjadatta is happening in our country, and that's the proud thing which we all are the contributor for the same. This is a very good initiative by IMR. Just to introduce what is Praj is doing, we are in the more than now 100 plus countries, 1000 plus projects we build, more than 300 plus patents built by the Praj on the biofuel sector by using different crops, different products. And this is global rank 1 for the technology engineering, where we build the project in all developed and developing countries. And most importantly, whatever today's India's ethanol has been produced, it is produced from the Praj's technology more than 70%. And global 10% ethanol, which is produced where we supply the projects and technologies. And very importantly, this company is founded by very, what we can say, visionary leaders, Dr. Pramod Chaudhary, who is belong to Maharashtra. And very proudly, this company has also received the George Washington Carver Award and William C. Homer Award with his personal efforts. So if you see the energy transition, where farmer is the backbone of energy transition now, and by considering the COP26 reports or your targets of emissions and Atmanirbhar Bharat and increase the productivity, the major objectives what our nation has been guiding us to complete the target of Atmanirbhar, and considering the existing geopolitical scenario of wars, where we got stuck into our essential energy supplies. which has given us another pinch in the heart that why India can't go ahead with Atmanirbharta under our farmers backup, where we are as an agrarian country and we have to build our nation with our own energy sources. And that's where from last 40 plus years, this company is building new technologies for the agriculture produce to generate different types of biofuels. So that I'll try to cover it so that along with the maize, how what we can do better in the bioenergy sector that can be very deeply elaborated. So now the time has come when ethanol blending gasoline is running with E20 models across the country. Now E85 has been launched, and for E85 there is a very clear distinction of flex fuel vehicles which are going to be present in the market by say July, August. So E85 will be used by those vehicles, not existing vehicles, and E20 will be used by the existing vehicles. So now our country is transiting towards Atmanirbhar things, where farmers produce has been considered as a backbone and used for the production of the biofuels. And those biofuels are replacing the import of our country, and the imported money which has been saved from the import of crude or import of other things that come back to the infrastructure development and agriculture development. That's why we have to reimagine the mobility. So air, if you see the graph now, aviation has been coming out with the blending fuel in few years. So 1% blend, 3% blend, 5% blend we have to do. Road transport from diesel, petrol, and all those stuff. Now it is going towards the ethanol blending, then ethanol, alcohol blend into the diesel, then EVs. Similarly with the marine. So today we are using the bunker oil. That bunker oil in future are going to replace by the biofuels. Why I'm emphasizing on biofuel and agriculture link? Because everything is produced, whatever the fuels produced in the bio sector, these all are produced from the agricultural crops. There is no other theme which is available as an Indian, what we can say, agrarian country, to reduce the GHG and to create a import, self-reliance, to reduce the import, and even for the create a rural job infrastructure with this entire thing and get a good value, fetch a good value of the product. So these are the avenues of, we can say, application of agricultural crop residue in different sectors. Now what dream is coming out in the picture very clearly, there are different mobility structures, right? Biomobility, we can call it. So biomobility, when you say that there are technologies which can produce the different fuels. So everybody knows that sugar and starch are used for the production of ethanol. When I use this sugar and starch, we call it as a 1G ethanol. Then there is a cellulosic ethanol. When I use the crop residue for the production of ethanol or biofuel or advanced biofuel, we call it as a second generation ethanol. Then compressed biogas, similar residue and industrial waste used for the production of gas, purified, and then use it replacing the CNG. Then we called it as a CBG technology. Methanol is coming out in the market. Biohydrogen is another. Then sustainable aviation fuel, which is used for the replacing of jet fuel. And then marine biodiesel. So these are different technologies or biofuels which are coming out in the different parts of the world. And India is having the potential to lead the world by producing the in-house fuels, not only for the consumption in India, but also we can export such good quality fuels. And to produce such quality fuels, whatever the technologies has been built by the Praj Industries, we are working it from last, say, 40 years. I am working with the Praj, say, more than now 18 years. So very clear concept and guidelines for the farming to build the global leadership is farm to fuel. Any raw material which is produced in the field as an energy, and that has to be very effectively used by the technology, innovation, solutions, scale, and optimize it for the requirement of the end consumer. So this is how a vision has been built to create a sustainable solutions for the environment, for the farming community, for the all stakeholders, vehicle application guys and all. If you see, it's a very simple bedrock success of any project. If you consider, when you start with the feedstock, you have to know what feedstock you are having, then which type of technology you are going to apply, and what product you are finally going to get it. So if I use sugary feedstock, I'm able to generate, say, ethanol. Other than that, ethanol, what I can do, I can produce renewable chemicals, that is bioplastic. If I use starchy corn, rice, any starchy material, which is having, say, good starch amount, can be fermented further, similar product can be produced. As I mentioned, lignocellulosic, either it's corn cobs, it's your bagasse, your wheat straw, paddy straw, corn store, anything which is having cellulose in the composition can be converted into second generation ethanol, that is a low carbon ethanol. Similar feedstock will be used for the production of compressed biogas. Similar feedstock will be used for the production of renewable chemicals and biochemicals. And if I say that when sustainable aviation fuel is produced, all these ethanols will be converted further for the production of sustainable aviation fuel. So first base molecule is sugar or starch or lignocellulosic sugars. Convert those into the ethanol or higher low carbon ethanol and produce further sustainable aviation fuel. So these all projects are now under different stage of, say, construction, commissioning. 1G ethanol is largest produced in India. 2G ethanol, already 3 projects under operation, and 1 project is under commissioning. SAP project under construction. Lot of CBG projects we are seeing around the world. Renewable chemicals and materials are also under construction, and other countries has built that one. And of course, the industrial or your we can say agro processing waste. That is a very good source of your methane for the production of CBG to replace the existing CNG. So finally, it's not only terms say that farmers are not only not producing food fodder, but majorly the fuel part also. I'll just brief you on in short that which are the different biofuels and what the technology and how it works. So corn, I'll not brief. Already, you know, you are growing the corn. I'm also a farmer, so I'm growing the yellow corn in my field. And 65 to 75 is the range what I'm able to get it from the starch level in my field. Now, this is how I'll say that these are the focus areas. Now, if I say that corn or maize is having, say, grain or kernel, corn cobs after threshing out the grain, and corn stalk or stover. So if we utilize this entire carbon, which is sequence, or what energy it has been gained from the seed to its final product, everything will be used. And nowadays it has so advanced that people previously say first generation ethanol means जो corn से बनाया गया वो. But now if I use the bran with the corn, it is used as 1.5G, which America is using. Then corn cobs, after removing the grain or seed, we can use the cobs, and cobs is high cellulosic material. So if 1 ton of corn grain is able to produce, say, roughly 380 to 400 liters of ethanol, 1G ethanol. If I use the corn cobs for production of advanced biofuel, 2G ethanol, 1 ton of corn cob will produce roughly 320 to 330 liters of 2G ethanol, which is low carbon ethanol. So this is how the potential is there in the different parts of the plant. And those parts, we have to use it, collect it effectively, supply it to the refineries, or we have to build our own refineries on those raw materials. Similarly, all cellulosic material, whether it's tower, it's straw, it's any grasses, these are the roots to produce the ethanol. So see, these are different raw materials, what we use and successfully produce the ethanol at large scale, not say 1 liter or 2 liter, but it's lakhs of liters has been now started producing in Panipat, Batinda, Bargarh, and of course, some of the projects are on international. So these are the combination, these we regularly seen around our field. And if we can establish a proper supply chain for this raw material to collect and supply it to the near about projects, it is another business model we can see along with the biorefinery. So this is a value addition when you say that corn only ethanol can produce. No, there is also a germ which contains a good quality of oil. If you see that fat and fibers and ashes, it also contains a good quality oil. So oil can be extracted from the corn. Previously, this technology was not available. Now it has come very strongly. And if I use the corn DDGS, I'll just explain first and then I'll come to DDGS part. That if this Indian corn and US corn, if you see the fats and oils, we are roughly 3%. And if I'm able to extract this oil from the process and use it for the production of my biodiesel or my sustainable aviation fuel, then we assume that roughly say 500 crore liters of ethanol today is produced from the corn alone. Minimum 2% of that one is also coming as a oil. So that oil can be easily used for the production of biodiesel or sustainable aviation fuel. So as Sachin has already mentioned in his, that 45 million metric ton is going to be expected to be produced. So I think 21 to 22 million metric ton will go towards the ethanol production. And out of that, 3% is there. Means we can produce a good quality and volume of oil into the ethanol industry. So what is the process for oil production? This is corn milling. You know that how all the mills are producing the starch. So we have to grind it, atta banana hai. Then liquefaction is nothing but aate ko ferment karna hai. It's a very simple methodology. Then you have to distill it, whatever the enzymatic hydrolysis ke baad, whatever the distillation is doing to purify the ethanol. And through screening or solid liquid separation, decantation is happening. And through this decantation, then it is a evaporation. And parallelly, when your DDGS is coming out, dry distillate grain solids in the distilleries, which are used for the production of animal feed, before that, you have to extract the oil so that you can get the better value of that oil. So this can be the side business along with the distilleries. Any entrepreneur can set such units. Then coming to 2G. As grain I use for the production of the 1G ethanol, oil I extracted, then why 2G is there? So 2G is majorly focused on to grow the or to boost the rural economy, reduce the carbon footprint. We have seen that in Delhi smokes and all those news always been there. क्योंकि पराली जला देते हैं, ऐसे बोला जाता है. Then if I'm using the paddy straw or corn stalk or corn cob for the production of biofuel, and which is reducing my greenhouse gas emission, reducing my import, creating the rural infrastructure, job of supply chain, and I'm not going to depend on the foreign countries to buy mujhe oil supply karo. So if I'm having that raw material in my country, why I should go for others? So that's why 2G came in the picture. Economic opportunity for rural boosting is the key behind that one. And that's where the supply chain management has happened. And new technologies started evolving, and those entered into the very, we can say, scalable models, where from 5 liters it went to 10,000 liters. From 10,000 liters it went up to now 1 lakh liter. 1 lakh liter now yearly production will be 3 crore liters. So all those projects are going to make a sustainable view in this 2G space. To explain it will be little bit technical, but if you see any paddy straw or corn stalk, the structure is like this. Plant is standing because of the lignin. This outer yellow cell wall is nothing but the lignin bonds. And inside the yellow maize, there are the cellulose and hemicellulose sugars. Those sugars need to extract. That's where the technology plays a part. Once we extract those sugars from the plant, this will give a free sugars to ferment. And then similar like our आटा बुनते हैं फिर बाद में ferment करते हैं, similar steps will be happen in this. So these are the structural changes, and for each feedstock these structures are different. So corn feedstock is different, paddy straw is different, wheat straw is different, but overall the composition wise the percentage will be changed, and the structure will be sometimes in cotton stalk. This yellow mesh is going inside, like that structures are happening. So woody biomass, it is always been a higher lignin side. Now, if you see the composition, that's what I'm explaining. First three components, cellulose, xylene, and lignin, are the key components. More the lignin, less the ethanol. But more the lignin, more the strength, which is having good calorific value. And for ethanol production, we always see that less lignin, higher cellulose and xylene. That's why corn cobs are the better composition for ethanol. So any feedstock which contained cellulosic sugars is having the potential to produce 300 to 150 liters range of ethanol per ton of your biomass. Now multi-feed, how it is happening. So this is 2G process. Now if you see the biomass handling, then you have to crush it, retreatment, then I also go with the acid steam, then your enzymes coming in picture, then distillation, fermentation, distillation. These two things at the bottom are very crucial. Vitamin, along with the ethanol, this lignin part is playing a crucial role. If I extract that lignin and able to produce the bitumen, which is a replacement of fossil bitumen. Today we conducted trial and we seen that up to 20% blend is happening with the fossil bitumen, जो रोड बनाने के लिए काम में आ रहा है. So these are the testing results of the road. So this we constructed 3 years back, and we found that this has been inaugurated by other ministers also. And this road is now having better strength when I'm using this lignin converted into biobitumen and blend it with fossil and constructed. So this road is now certified, verified, tested in India, tested by Indian scientists, tested by foreign scientists, and they are given the certification that now this vitamin can be used. So if you see another molecule along with the 2G ethanol, now if you see the gas, any raw material which is having similar composition, हमारे गांव में बायोगैस बनता था. So similar type of biogas in large scale. So further you have to purify the gas, and scale has to be on the larger scale. So all those gas need to remove the CO2, need to remove the sulfur, and then compress it, fill in the cascade and supply it. So government of India come out with the scheme called Satat. Now it will be Sampurna. So in that scheme, 15 million metric ton CBG need to produce to replace the CNG. And for that 5,000 projects across countries, so that we should not ask other countries to supply me the gas of LPG, gas of CNG. So we want to reduce the import, and all this material is available. In industry, your press mud is available, corn cobs are available, then your straw is available, stock is available, cow dung is available. chicken, poultry litter is available. So all that can be dumped into the digester, and digester will produce the gas. That gas need to further purify. After purification, remove the sulfur, compress it to 50 bar, fill the cascade and sell it to the customer. And all this uptake is happening through the oil marketing company. This is called under Satat. And MNRE has provided a lot of schemes. Different state governments have launched their CBG missions, biogas missions in our country. So everybody has to take the benefit of such schemes or different small scale projects, say 3-ton, 5-ton capacity projects of gas production. Now, another value chain, when you produce the gas through the system, you are generating the biomanure. From this biomanure, two products. One is going directly to the farm by valorizing it, but आप ऐसे ही कीचड़ लेके फिर से डंप नहीं करना है. It has to go with the proper valorization. You generate a good revenue out of that one. So you can take out the moisture from that, prepared a standard operating process. I think ICAR and IMR already built these SOPs along with Raj Weaver. And this FOM, fermented organic manure, is a good source of carbon to replenish the existing soils. It is not source of NPK. It is a good source of your carbon. So organic carbon बढ़ाने के लिए, this is the best way to create a valorization into the FOM. Parallelly, liquid FOM is also coming out from the process. That is a good source again for the organic carbon and very good bacteria which are going inside the soil that can generate or take out the existing potash, existing phosphorus, existing nitrogen by adding azotobacter, or your, of course, the potash solubilizing PSB and KSBs. So all those mixtures, if we go according to the practices of the crop cultivation, along with the supply chain model, this is another area where rural entrepreneurs can think around the CBG projects. Then coming to aviation fuel. So sustainable aviation fuel is nothing but when we produce the ethanol, that ethanol further has to go with the certain channels. And that channels, sustainable aviation fuel is a long carbon chain. And alcohol has to go further for hydrogenation and oligomerization and then produce the sustainable aviation fuel. So now this is the requirement of our country also, because in oil refinery, when you see once crude in, then these products are coming out. Now once our bio feedstock or biological multiple feedstock coming inside, multiple products started generating. And this is now not a dream. We proven to the globe that our country, our technologies are much more better and superior than the existing external world, so we can be self-dependent. This is the pilot project, India's first pilot or Asia's first pilot project, where end-to-end integration of SAP has been produced, and that we blended with the along with the help of Indian Oil and blended into the jet fuel. Air Asia was the flight, and that flight, first commercial flight from Pune to Delhi sector, has been flew. And this is the plant where this configuration has been built in-house, and now it is ready for the commercial scale, produce a 300 kiloliters per day capacity of the projects. Now coming to marine. Now say same feedstock. When residues coming out, you can valorize. Now lignin can go to biobitumin, lignin can go to lignosulfonate, lignin base oils of this corn, BCOs and all will go towards the marine, because this is a bunker fuel. And as per now international, what we can say norms, we have to reduce the sea or oceans pollution also, that we called as a blue ocean strategy. So under blue ocean, farmers are going to play a very big role, not only say in the range of say who are producing the corn or wheat, but also the coastal farmers. Those are now going to cultivate the different feedstock, food, fodder, fuel for the marine also. because oil is the backbone, and different oils, either it came from your corn oil or you are extracting the oil from the lignin. These are going to produce or through the pyrolysis route to the bio oil. These are the sources of feedstock which will be used for the production of marine. Then hydrogen. So from same gas, if you steam reformer systems is used, then your gas further get value, what we can say as a valorize further, increase the strength and produce the hydrogen. So it's electrolyzer is one technology, and second one is the steam reformation technology. So instead of using the water and heavy electricity, if you go with both the technologies are good, but here the raw material is used as a gas, biogas, so that my farmers got connected. So that's why we are thinking that steam reformation for the production of hydrogen is directly connected with the farming community, and it will give the boost. Now, major emphasis as UP government has also come out with the biochemical policy from production from the same, either it's starchy feedstock, sugary or lignocellulosic. So when our country has now reached the 20% ethanol blending program and E85, E100s are now on the way, we are also having this tremendous potential to valorize the agricultural produce for the bioplastics. So what is bioplastic? It is made from the lactic acid, that is polylactic acid or polyhydroxy acid. And source, what is the source? Of course, this is the starch, sugar, and cellulose. So all three are produced in the agriculture. So from same refinery, if I can convert the sugars one pathway or starch in one pathway, then I can produce the biochemicals. And this is impact is going to be a humongous under the bioplastic sector now. We don't now require the foreign technologies to get implement faster in India. We are having now our own technologies. Lot of big value chain is required for this sector to grow, and a lot of entrepreneurship will happen in coming days with the skill developments. So bioplastic is another technology when same residue, agricultural residue, will be used for the production of biochemicals, either it's PLA, PHA, polyhydroxy acid, lot of things. Now, that's why the newer dimension of agriculture is now in the forefront to the country. And we found that if we connect, coordinate, and educate the entire ecosystem which link to the agriculture, we don't want to lose the carbon, which has been sequenced very potentially by our farmers, by ourselves. That has to be used very effectively rather than digging out a carbon from the soil below the ground and put that carbon into the atmosphere. Now, this year monsoon, we are seeing a lot of changes has been already observed by different peoples, different countries. So all those ecosystems, we have to create now the circular economy. And for circular economy, every product which is coming out with industrial bioprocesses, that has to be a biological processes and need a value for each product. And there the real entrepreneurship will come out. For example, DDGS valorization from the corn, oil extraction from the corn, stock collection supply chain for the corn, compressed biogas decentralized models, slurry preparation models, poultry. If I set up poultry, within poultry chicken litter with my cow dung, can I set up biogas plant? FOM coming out from the process, can it be sold it back to the agriculture field? So these are all what we can say parallel, aligned, complementary businesses which need to generate in India very strongly to boost the circular economy. Then we can say really that yes, circular economy for Atmanirbhar Bharat is now working with our generation and with the guidelines of senior people who are spent their lives for the developing Atmanirbhar Bharat. That's what the dream is now. Make in India and made it for India, and we can export to the globe. So whatever if you today you see, whatever crude can produce, CNG, gasoline, naphtha, kerosene, diesel, blah, blah, things. If I use my corn, if I use my agricultural crops, if I use surplus damaged grains, right? We are not using for ethanol production any food grade things which is consumed by the humans. For ethanol production, there was a misconception that food versus fuel. No, we are using the surplus damaged food grains which are not consumed by the humans that use for the production of biofuels. The residue which is get burnt, not used properly, that used for the production of biofuels. And all those can be replaced, the import of this left hand crude to the right hand self-Atmanirbhar. So we can produce gas, CNG will replace CBG. Already we are replacing strongly the gasoline, which is imported thing, biochemicals, jet fuel. So we are producing sustainable aviation fuel, diesel to replace renewable diesel, bio oil, biofertilizer, biobitumen. So entire refinery, any agri product you put inside, multiple products can be generated for the India. And that can be possible only when the integration of farming community to understand the value of the product and decentralized models of such small biorefineries will start working in India. Now, when previous already Sachin has explained the carbon credits, that's why I was very interested in that. That LCA is a key pattern which is going to play a very crucial role in future, because international norms we have to follow, and for the corn we have to reduce the carbon footprints for production of the biofuel, which is going to qualify for the export or to produce the sustainable aviation fuel. So where we are putting more fertilizer, or we are putting more efforts or consuming more machinery diesel for the cultivation, logistic, transport, all is going to be considered for the carbon emission. And if my raw material is low carbon emission material, then my product is low carbon and which can be generate a very good revenue for the country and farmers. So whether either I should go with the intercropping model, just like in sugar cane area, sweet sorghum and sugar cane is now going to be a very popular model for the low carbon ethanol. Similarly, corn, cassava can be uploaded, or corn, ratoon corn, sugarcane can be taken as a crop. So multi-feed approach is required for the agriculture farming also. So there has to be multiple options as per the requirement of the market and industrial development. And I request IIMR and ICAR that whatever the biofuel policies government has launched, it has to be need circulate to the all the farmers in their own territorial languages, so that they can also see the participation in higher percentage. So agriculture, if I go with 4A, now Dr. Saab is telling 6A. So these are the different pathways. You can go immediately with the developmental models or industrial models at the scale. Supply chain is a one model, ethanol production or DDGS, animal feed, organic manure, bio oil, DDGS. See, simple one crop can produce multiple things with the efforts of industry, academia, and farmers together, and create a, we can say that, self-resilient, energy-resilient villages. So one biogas project has clear 100 houses. So 5 ton can produce roughly, take out the cylinders of 100 chulas. So such economics has to be play. Now there is a time that people like all our young generation, all experienced people has to come together and they has to work now for the country to build such a very attractive, self-sustainable, economically viable models for the rural areas to build their own energy strength. And these are, I think, different opportunities, what I observed in last 5 to 8 years. So inclusion of biofuel, bioeconomy subject in agriculture curriculum is another opportunity I can propose to ICR and IIMR, that this need to be educated to the students who are coming out or passing out from the universities so that they can go stabilize their things outside. Farm-allied businesses, it has to come from the state and central governments as a supportive policy for the structuring the farmers' growth in the catchment area of any biorefinery. This is what I can try to cover in a short period of time, because each topic required a day to explain. But as Dr. Lal Saab has already mentioned me that you have to cover the biorefinery concept also. So I thought, so let us cover the different technologies so that everybody start thinking in this direction, that how the technologies can valorize the agricultural byproducts and further giving more returns per acre. Finally, aim is same. So it should not be compromised with the climate damage. It should not be compromised with deterioration of the health. So we have to see all balance, but finally revenue per acre of the farmer has to grow. And that's what the technology adoption or product utilization in right direction is the key for the success. Thank you very much.
Thank you so much, sir. I think we have two questions in the chat box, sir. So we can take up that those two questions.
How to get fermentation sludge recycled back in order to improve alcohol yield as well as improve DDGS yield from maize-based ethanol plant. So it is a process parameter what has been asked for the sludge. So after the sludge, you are maximally you are doing the DDGS separation, solid liquid separation, and solid liquid anyhow it is going back to the system, but solids you have to dry it further. And the major challenge what today we found in the maize is carrying out the aflatoxin. So aflatoxin removal from the corn system is crucial for the DDGS sector also and poultry sector also. And that's what Sachin told, that storage and all infrastructure. But coming to your answer, yes, we have to do the proper solid liquid separation effectively with the decanters, and then decanters sludge need to be get dried further for the production of good quality DDGS. SAP you can recycle back, and that contained say roughly 0.2 to 0.3% of the waxes, but say 3 to 4% of your starch also. So that will improve your ethanol yield. So there we can say as backflow reactions for the production of ethanol. Second question, please explain about ethanol cost per barrel produced from 1 gram and 2 gram, 1G and 2G. Oh, so cost not only depend on the process parameter, Guptaji. Some cost depend on your feedstock cost depend on your power cost, water cost. But still, I'll say that when I use the corn to ethanol production, production cost is roughly say 40 to 45 rupees. Sometimes when prices goes here and there and power plays a major role, it goes up to say 48 to 50 rupees per liter. And when I consider the 2G ethanol, when corn cobs or corn stover, without considering the feedstock cost, because feedstock cost is yet to what we can say stabilize in Indian market. But still, I'll say 2,500 rupees a ton or 3,000 rupees a ton of corn cob. This will roughly goes up to 72 to 80 rupees a liter for production of 2G ethanol.
Thank you, sir.
Button.
Thank you so much for your response.
Welcome, Doctor. Welcome. We can discuss in detail.
Yes,
If,
yes, I would like to discuss with you because I'm associated with the distillery industry in Sansarpur Terrace, Himachal Pradesh,
Great.
and we are just producing and recycling this sludge, fermentation sludge in our DDGS stream.
But please see the contamination challenge, Doctor. Thoda sa usme, if you go it back to the fermentation, there should not be the batch contamination when you recycle. That take care is more important.
Yes, yes, and I would like to meet and discuss you in more detail later on when you are having a time, and then
Sure,
you can
sure.
give a. Yeah. Thank you so much.
Anytime. There are a lot of technologies which can improve the further yield of the corn.
Yes, yes. Thank you so much.
Welcome.
अगर और किसी का क्या सवाल है तो बताइए, किसी का अगर सर से डायरेक्टली अगर पूछ सकते हैं.
Yeah, if anybody want to have a direct contact, please take down my number. I'll also put it on my number in chat box.
Yes, sir.
9766 42466. Dr. Tushar Patil. Raj. Industries.
Thank you so much, sir. We have got this one. If there is no further questions, then thank you so much, sir. And your suggestion for ICR and IMR that you have given has been noted, sir. And it is a good idea that you have suggested that remarks also. And thank you once again, sir, for insightful presentation. It was you have covered all the aspect of the industry sectors and how to produce and what are the opportunities and bioeconomy, sir. Thank you so much once again, sir, from ICAR-IMR, sir.
Thank you very much, sir. It's a pleasure to interact. Thank you very much.